Problem 5. If 3x squared plus 4x plus xy is 4 and y at 4 is negative 15, find y prime at 4. Okay, y prime means derivative of y with respect to x. So this is the x coordinate, this is the y coordinate. That's what they are telling us to begin with. Now, this is the equation of your curve. So take derivative with respect to x of both sides. Derivative of this plus derivative of this plus derivative of this equals derivative of this. Derivative of constant is 0. 3x squared. X and x same variable, so it's simple 6x plus derivative of 4x. X same variable, simple derivative y plus derivative of x times y. So that's a product rule. Derivative of the first, that's 1, second as it is, plus first as it is, derivative of the second, it's simply dy dx. All that is 0. You want to solve for dy dx, so take everybody else to the other side, negative, the rest, negative 4, 6x, y. And you want to divide by x eventually. Now, we are told when x is 4, y is negative 15. So you are going to plug in x equals 4 and y negative 15. So 24 minus 15 and this is 4. Alright. So there is an overall negative. Dy dx is same as y prime. You are evaluating at 4. By using these numbers, you get overall 28 minus 15, 13 over 4, the negative. Next problem. Find dy dx by implicit differentiation. X squared y squared plus x sine of y is 10. Take derivative with respect to x of both sides. Derivative of first term, derivative of second term equals derivative of 10. Derivative of 10 is simply 0. Alright. Here, this is product rule. So derivative of the first, second as it is, plus first as it is, derivative of the second. So 2y times dy dx. Notice y is different from x, so you need dy dx. Plus, again product rule, derivative of the first, that's 1, second as it is, plus first as it is, derivative of the second, so derivative of sine is cosine of y, but y is different from x, so you need a dy dx. Right hand side is 0. So get the dy dx terms together and the others together. So 2xy squared plus sine y plus dy dx terms together. So dy dx common factor, 2y plus x cosine y. Right hand side 0. Move this guy to the other side. So with the negative, all that came here. And you are going to divide by this expression to get dy dx equals negative this over this. So remember, negative numerator over denominator. Now we fill in each of these. Numerator 2xy to the power 2 plus sine of y. Denominator 2x to the power 2y plus x cosine y. And make sure there's a negative outside. Alright. Next problem. Derivative of this equation. So you want dy dx. 8 plus x equals sine x y squared. Derivative of both sides. Derivative of the first plus derivative of the second equals derivative of the third. Derivative of constant 0, derivative of x is 1 equals, so this calls for chain rule. You see, sine and something inside. So, outer derivative. Sine, derivative of sine is cosine inside is as it is, times, now the chain part, derivative of inside, that's product rule. Derivative of the first, second as it is, plus first as it is, derivative of the second, so that's 2y and dy dx. Dy dx because y and x are different variables. Okay, all this is being multiplied here. So notice in this equation, dy dx appears only once. So there's a plus here, so open it. Left hand side is 1 equals cosine xy squared times y squared plus 2xy cosine xy squared dy dx. Move this guy to the left. I get 1 minus cosine xy squared times y squared equals 2xy cosine xy squared dy dx. I'm rewriting it with this on the left just for visibility, and then divide both sides by this factor. 1 minus cosine xy squared y squared over. So that's your derivative. Alright. So numerator over denominator. Numerator is 1 minus cosine xy squared times y squared. Denominator is 2xy cosine xy squared. Alright, so next problem we'll start on the next video.